We want to start our work with solving trigonometric equations. Here's the first one I've written on the board. Let's solve 2 cosine theta minus square root 3 equals 0. We're going to treat the whole expression cosine theta as if it was just a single variable. So I'll start by adding square root 3 to both sides. 2 cosine theta is equal to square root 3. Next, I want to isolate cosine theta on one side, so I'll divide both sides by 2. Cosine theta is equal to square root 3 over 2. Okay, so I'm looking for all values of theta, first of all, between 0 and 360 degrees that make this a true statement. So the fact that cosine theta is square root 3 over 2 tells me that my reference angle in this case is going to be 30 degrees. Then I ask myself, okay, where is cosine positive? Cosine theta is equal to positive square root 3 over 2, so where does that happen? Well, cosine theta is positive in quadrants 1. Okay, so 30 degrees in quadrant 1. And since cosine goes with the variable x, I know that cosine is positive in quadrants 1 and quadrant 4. So I'm going to draw in a reference angle of 30 degrees in quadrant 4 and name this angle as 360 degrees minus 30 degrees, which will be 330 degrees. Okay, so right away, if cosine theta is equal to square root 3 over 2, that tells me that the reference angle is 30 degrees. Then I know that there's 2 possible angles between 0 and 360 that have this for a reference angle and are also positive. So, and where the cosine of them is positive, and that's going to be in quadrants 1 and 3. So that tells me that theta is equal to 30 degrees and theta is equal to 330 degrees. Now, suppose I want to write all solutions. Well, I only have 2 between 0 and 360, and then I can add on any multiples of 360 to those, and I'll end up with an angle coterminal to them. We'll have the same cosine. So when I want all solutions, I write down theta is equal to 30 degrees plus 360 degrees times k, where k is just an integer, 0 plus or minus 1 plus or minus 2, so on and so forth. And then the second solution is theta is equal to 330 degrees plus 360 degrees times k. So here's my solutions between 0 and 360. Here's all my solutions to that equation. Find the reference angle, check the sign, the algebraic sign plus or minus of the trig function. That tells you in which 2 quadrants you go. Write your reference angle in those 2 quadrants and then name the angle that that has those for a reference angle. Let's try another problem. Okay, here we have an equation, 4 sine t minus square root 3 equals 2 sine t, and I want to find all radian solutions to that equation and just the radian solutions between 0 and 2 pi, including 0 but not including 2 pi. Let's see. So I'm going to start by adding negative 2 sine t to both sides, so I'll get 2 sine t minus square root 3 equals 0. Now I'll add square root 3 to both sides. 2 sine t is equal to square root 3. Then I'll divide both sides by 2, and I'll get sine t is equal to square root 3 over 2. Okay, well, I see sine t is equal to square root 3 over 2. That means, that tells me that t must be equal to, or the reference angle for t must be equal to 60 degrees, or, well, let's do that, 60 degrees or pi over 3 in radians. I generally tend to think in terms of degrees, and so I might write the degrees down first, and I know my answer should be in terms of radians, so I'll write down the pi over 3. Okay, so if that's the reference angle, and it's a sign that's positive, so the sine function is positive in quadrants 1 and 2, then I can write my reference angle down like this. Okay, reference angle of 60 degrees looks like this. 60 degrees equals pi over 3, so that's 1, and then also I want the reference angle in quadrant 3 because it's a sine function and sine's positive in quadrants 1 and 3. So I'll put my reference angle over here again. this is 60 degrees, equal pi over 3. Okay, and then I want to name this angle right here. And I want to do it in radians, so that looks like, let's see, that'll be pi minus pi over 3. So pi minus pi over 3. Well, that's 3 pi over 3 minus pi over 3, so it should be 2 pi over 3. And that makes sense. So if sine t is square root 3 over 2, a positive number, then the reference angle is 60 degrees, which is pi over 3, must be in quadrants 1 or quadrant 2, in which case I'm going to get angles of pi over 3 or 2 pi over 3. So I'll fill this in first. T is equal to pi over 3 or 2 pi over 3. So those are my two angles in between 0 and 2 pi written in radians. And then all radian solutions, I'm going to add on multiples of 2 pi to this, because any time I add on 2 pi, I get an angle coterminal with my original angle. I had a little malfunction with the camera there, so let's finish this problem here. We had all solutions between 0 and 2 pi was pi over 2 and 2 pi over 3. When we want to write all solutions, what we do is we add on multiples of 2 pi. Since our original solutions here between 0 and 2 pi are in radians, we'll add on radian multiples right here. So 2 pi times k, 2 pi times k, that's what we add on. K is any integer, 0, plus or minus 1, plus or minus 2. Then we get all the possible angles that are coterminal with these two. There's an infinite number of them, each of which is a solution to the original equation. Here we go with the next problem. Okay, here I have another trig equation. 2 cosine theta minus 5 is 3 cosine theta minus 2. Let's solve this equation. Let's see, I have 2 cosine theta here, 3 here. If I add negative 2 cosine theta to both sides, I'll have negative 5 is equal to cosine theta minus 2. And now I can just add 2 to both sides and get negative 3 is equal to cosine theta. So negative 3 is equal to cosine theta. What does that mean? Well, let's take a look here. I can draw my graph in. Let's put in 360 degrees and 180 degrees. Here's negative 1, positive 1, and let me graph just a quick little sketch of one period of cosine theta. It's going to look like this. Okay, so where is this going to intersect the graph of y equal negative 3? Well, y equal negative 3 is going to be down here. That go off the board? No. It will never intersect that graph. So there's no solution to this equation. Cosine theta has to be between negative 1 and 1. It can never be negative 3. No matter what you do, if you put a negative 3 on your calculator and look up the angle whose cosine is that, you're going to get an error. So in this case, the solution set is the empty set. Here I have sine x plus 2 sine x cosine x is equal to 0. I'm going to solve this equation by factoring. I'm going to factor out the greatest common factor, which is sine x. Watch what happens when I do that. I'll factor out a sine x. What's left in this term is a 1, plus, when I factor sine x from this term, what's left is 2 cosine x. Just like if I was solving a quadratic equation in algebra. So I have the product of this factor, sine x, and this factor equal to 0. So to solve this equation, I'm going to set each factor to 0. So over here I'll get sine x is equal to 0. And over here I'll get 1 plus 2 cosine x is equal to 0. Well, this tells me that x must be what? Where is sine x equal to 0? Well, let's take a quick look at the graph of y equals sine x. So I'm going to draw the graph in right here real quickly. Y equals sine x looks like this. There's 1, there's negative 1, 2 pi, and pi. Okay, where is sine x equal to 0? It's 0 here, here, and here. So sine x is equal to 0 implies that x is equal to 0 or pi or 2 pi. Now how about this? 1 plus 2 cosine x equal to 0. Well, I have to solve for cosine x. I'll add negative 1 to both sides, then divide by 2. Cosine x is equal to negative 1 over 2, negative 1/2. So that tells me that the reference angle is going to be, when is cosine 1/2? Well, cosine is 1/2 at 60 degrees. So the reference angle is going to be 60 degrees, which is the same as pi over 3. So again, I'll draw a little diagram here to help me out. Okay, I want 60 degrees. Cosine is negative where? Well, cosine goes with the variable x, and x is negative in quadrants 2 and 3. So here and here is where cosine x is negative. So I want to draw in a reference angle of pi over 3 in quadrants 2 and quadrant 3. So I'll draw in the reference angle here, 60 degrees, which is pi over 3, and the reference angle down here, 60 degrees, which is pi over 3. Okay, so what are my two angles? My one angle right here is this, which will be pi minus pi over 3, which is 2 pi over 3. And then this angle, which is going to be pi plus pi over 3, so 3 pi over 3 plus pi over 3, 4 pi over 3. So this angle, which is going to be pi minus pi over 3, and this angle, which is going to be pi plus pi over 3, or 4 pi over 3. Okay, so where are all my solutions between 0 and 2 pi, including 0 but not including 2 pi? Well, up here I got 0 pi. I'm going to leave that one out because of this strictly less than symbol. So x is equal to 0 pi, and x is equal to 2 pi over 3 and 4 pi over 3. Oops, a little malfunction with the recorder again. Let's look at the end of this problem. Here we had our solutions for x between 0 and 2 pi. They turned out to be 0 and pi, 2 pi over 3 and 4 pi over 3. Okay, now we want to write all solutions. Well, first when we look at this 0 and pi, remember that it came from this graph. Looking at where this graph of y equals sine x crossed the x-axis. Well, that happens at 0, pi, 2 pi. It'll happen again at 3 pi, 4 pi, 5 pi. In this direction, negative pi, so on and so forth. So we can just sum up all solutions like that this way. Pi times k. It's going to cross the x-axis every pi units on the x-axis. So let's just say pi times k. That takes care of all solutions that come from these two right here. Now for all solutions from these two, we just add on multiples of 2 pi like we did previously. Multiply by k right here where k is an integer, and you get all the angles that are coterminal with these two angles here that are between 0 and 2 pi. Okay, so individual solutions between 0 and 2 pi, here's all solutions to that equation. All right, let's look at another problem. So here I have an equation that's quadratic in cosine theta. It's 2 cosine squared plus 11 cosine theta equals negative 5. Looks like a quadratic equation, so I'll put it in standard form and see if it factors. So 2 cosine squared theta plus 11 cosine theta plus 5 is equal to 0. When I add 5 to both sides, I get plus 5 over here equals 0 on the right side, so I've got it in standard form for a quadratic equation, just as if it was a quadratic equation in x, but instead it's a quadratic equation in cosine theta. Now let's see if we can factor this. I hope it factors. If it does, these first two terms here, when I multiply them, I'll get 2 cosine squared. So how about 2 cosine theta and just cosine theta? Now the two numbers that I put here have to multiply and give me 5, and then when I multiply inside and outside I have to get 11 cosine theta. So let's try positive 1 and positive 5, because I know I can multiply those and get positive 5. Inside I have 1 cosine theta, outside 10 cosine theta. That adds up to 11 cosine theta, so I factored it. Let's set our factors equal to 0. 2 cosine theta plus 1 equals 0. Or cosine theta plus 5 equals 0. Well, look, I can take care of this real quickly. Watch. I'll add negative 5 to both sides. Cosine theta is equal to negative 5. Guess what? That can't happen. Cosine theta always has to be between negative 1 and positive 1. It can never be negative 5. So I'm not going to get any solutions over here. So for that part of the equation, I'll just write the empty set. No solutions. Let's go over here. I want to solve for cosine theta. So I'll add -1 to each side, then I'll divide both sides by 2. So I get cosine theta is equal to -1/2. That tells me that the reference angle for theta is, well, where's cosine theta 1/2? At 60 degrees. So the reference angle is 60 degrees, and then it's a cosine function which is negative. Well, cosine is negative in quadrants 2 and 3 because cosine goes with the variable x, and x is negative in quadrants 2 and 3. So let me go over here for a second and let's see if we can write down a little diagram. Here's 60 degrees in quadrant number 2, and then here is going to be 60 degrees in quadrant number 3. So what are the two angles I get out of this? Well, first of all, I get this angle, which will be 180 degrees minus 60 degrees. So 180 minus 60, which is going to be 120 degrees. And then I get the second angle, which is this, which will be 180 degrees, right, over to there plus 60 degrees. And so that's going to come out to be what? 240 degrees. Okay, so I get 240 degrees there. So what about my solutions? Well, if the reference angle is 60 degrees, cosine is negative in quadrants 2 and 3. I get these two angles right here. Theta is equal to 120 degrees, or theta is equal to 240 degrees. Those are all my solutions between 0 and 360 degrees. If I want all solutions, then I simply add on plus or minus 360 degrees times k. And that gives me all solutions to that equation. So, quadratic equation in cosine, we factor it just like we would if we were factoring a quadratic equation in algebra, set the factors equal to 0. That gives us the reference angle, and from that we can find the solutions. I just looked at the tape and saw that I wrote plus or minus 360 times k, plus or minus 360 times k. I don't know where that came from, maybe the quadratic formula, but the way we're writing them here is 120 plus 360 times k and 240 plus 360 times k. Plus or minus is going to give you the same thing, but we haven't been writing that minus sign. Don't want to confuse you. Sorry about that. All right, here we have a quadratic equation in sine theta. 2 sine squared minus 2 sine minus 1 is equal to 0. Okay, this one doesn't factor, so I'm going to have to use my quadratic formula. Let's take a look. I'm going to say this. Sine theta is going to be, okay, by the quadratic formula, negative b, so negative 2 is positive 2, plus or minus square root of b squared, so 4 minus 4 times a times c, all divided by 2a. All right, let's simplify here. 2 plus or minus square root of 4, subtract 4 times 2 is 8, times 1 is still 8, and a negative times negative is positive, so I have 4 plus 8, which is going to be 12. All divided by 2 times 2. So let's see, 2 plus or minus, square root 12 is the square root of 4 times 3, so I'll simplify that as 2 square root 3, because 4 times 3, that square root of 4 comes out as just a 2, all divided by 2 times 2. Okay, I just want to do this and simplify as much as I can. I'll factor out a 2. 2 times 1 plus or minus square root 3, all divided by 2 times 2. Okay, finally those 2's divide out, and so I'm left with this simplified expression, 1 plus or minus square root 3 all over 2. And that is my sine theta. Sine theta is 1 plus or minus square root 3 over 2. Okay, so let's take each one of these separately, and let's see, I got enough room? Yeah. So I'm going to do this. 1 plus square root 3 over 2. Okay, that turns out to be, let's see, I did it over here, 1.36. Okay, that won't work. 1.36 isn't going to work for sine theta because sine theta always has to be between -1 and 1. It can never be 1.36. So that's not going to give us any solution. Let's try the other one here, 1 minus square root 3 over 2. And so that comes out to be negative 0.366. Go off the screen? No. Okay, so I'm okay. Okay, so sine theta is equal to negative 0.366. Now, what are we going to do with that? How are we going to find sine theta from sine theta equal negative 0.366? Well, if you put this negative number into your calculator, press the inverse sine button, you'll get one solution. But there's actually two solutions. So what I suggest is that you forget the sign right here. Change that back to positive. Enter just the number here itself into your calculator and find the inverse sine of that. When you do that, what you end up with is this. Okay, I'm going to take it over here, and I'm going to say this. You end up with the reference angle of 21.5 degrees. So I put in the positive number right here, the absolute value of this number, press my inverse sine key, and what I come up with is 21.5 degrees. That's the reference angle. Now sine theta turns out to be negative, the negative 0.366 in quadrants 3 and 4. So let me see if I can draw that in real quick. So I want in quadrant 3 a reference angle of 21.5. Okay, so that will be this, 21.5 degrees. And then I also want it in quadrant 4. So I'll go over here, and that will be my 21.5 degrees. Okay, so what do I have? I have two angles that I'm looking for. One is this angle, which comes around here like that. So that's going to be the angle 180 degrees plus 21.5. So 180 degrees plus 21.5 degrees, and that ends up to be what? 201.5 degrees. Okay, there's one of my angles. The second angle is this angle. The angle in quadrant 4 with a reference angle of 21.5, okay, that's going to be 360 minus 21.5. And that comes out to be, I think, 338.5 degrees. So there's one solution right here. Here's my other solution. You have to be careful on these problems because when you end up over here with the negative 0.366, you just go ahead and put inverse sine in your calculator, see what you get. You'll get one of these angles, but you won't get both of them. So what I suggest is forget that sign right here. Do the inverse sine on the absolute value of this. That will give you your reference angle of 21.5. Once you have that, then you know that the sine function is negative in quadrants 3 and 4. You draw your little picture right here, and you'll get your two angles out. Okay, cosine of a minus 50 degrees, that quantity is equal to square root 3 over 2. Well, we know with cosine is square root 3 over 2 that the angle must be 30 degrees, the reference angle. So I'm going to say this, a minus 50 degrees, okay, the reference angle for that is 30 degrees. So the reference angle is 30 degrees. Okay, and then cosine happens to be positive in quadrants 1 and quadrant 4 because cosine goes with the x-coordinate and x is positive in quadrants 1 and 4. So let's draw our little diagram here. I want a reference angle in quadrant 1 of 30 degrees. Looks like this. And I want a reference angle in quadrant 4 of 30 degrees. Looks like this. Okay, so where are my two angles? Well, my one angle is right here, okay, 30 degrees, and then my other angle is right here, which is 360 degrees minus 30 degrees, which is 330 degrees. Okay, so that tells me that this angle that I want, this A minus 50, is either equal to 30 degrees, or a minus 50 is equal to 330 degrees. So if a minus 50 is 30 degrees, I add 50 to both sides. Whoops, let me put my degrees in here. A is equal to 80 degrees. Or, in this case, I add 50 to both sides. I get A is equal to 330 plus 50 is 380 degrees. But now I'd like to write my solutions between 0 and 360. So 380 degrees is actually coterminal with just 20 degrees, right? 20 degrees plus 360 degrees is going to be 380 degrees. So I'm going to go up here and write my two solutions this way. A is equal to 80 degrees, and A is equal to 380 minus 360. I'll take that coterminal part off and just get 20 degrees. And then if I want to write all solutions, I'll take these two angles right here and add on multiples of 360, plus or minus 360 degrees times k. So every now and then you'll end up with a solution like this that goes past 360 degrees. Just subtract 360 degrees from it and you'll get your angle from that, and that gives me all the angles between 0 and 360 that are solutions. Adding on multiples of 360 degrees gives me all solutions to those equations.